Chapter 11, we're going to talk about trigonometric equations and identities. So first, some things about trig equations. Back in Algebra 1, we did a lot of linear equations, right? And we know that linear equations have exactly one solution. Right? Y equals mx plus b. There's exactly one time that's going to be that I can solve for x, get one answer. For a quadratic, we know we have at most two real solutions. We always actually have two solutions, but at most two of them are going to be real. And then for a cubic, right? I already talked about cubic before. Cubic, of course, would be if it was an x cubed, some type of equation, would have at most 3, and x to the fourth would have at most 4 real solutions, and so on. But actually, trigonometric equations, generally have infinitely many solutions. Unless, of course, I restrict my domain. We know that's true because we have a periodic function, whether it's a sine or a cosine, right? Well, that was a really poor sine or cosine, but you know what I mean. I'm going to get a lot of different answers. This continues both directions. Even a tangent, right, that wouldn't overlap so much, would still have infinitely many solutions, and so on. So typically we restrict our domain, right? There's my most common. That would just be, of course, once around the circle. We can solve these in a variety of ways. We're going to look here today about pre-prepared graphs. Next week we'll look at some technology defined, and then algebraically is the other piece. So solve where cosine of x equals 0.4 between 0 and 10, where x is between 0 and 10 radians using the graph. Well, notice this is a graph of y equals cosine of x. So this is graphed, right? And now I'm going to say, when does its y equal this, right? And the idea, just a little preparation for next week, when does y1 equal this and y2 equal that? If I count, each of these is one tick mark. So I can draw a line here at y equals 0.4, and I can see pretty clearly, I can look right down and say, well, that's 1.2. And look for the next one, and that's going to be about 5.1. And then that's going to be about 7.45. 7.45. I do the best I can to round. So x is going to be about 1.2, 5.1, 7.45, 7.5 or so. Again, do the best that I can. Maybe yours are going to be slightly off. This is a really good grid, so you can kind of tell that pretty easily. But I rounded to the best I can. We'll talk next week about being able to use technology, again, as a little spoiler, plugging in that y1, plugging in y2, and finding where they intersect. But we also know that my trig equations can be solved using my unit circle. If I have special values, I can solve algebraically or analytically. Right? If you're asked to solve analytical solutions or algebraic solutions, we're going to be looking at my unit circle. Now remember, sine and cosine, of course, have periods of 2 pi, and tangent has a period of pi. So if I were to actually solve this, for example, this example 0 without a restriction, where does the sine, we're thinking y coordinate on the unit circle, equal 1? Well, we know that x could be pi over 2. But also it could be negative 3 pi over 2. Or maybe I went around the circle 1 and then more times. So maybe that's pi over 2 plus another 2 pi, 5 pi over 2, right? Or so on and so on. The way we'd have to write this is actually going to look a lot like the tangent function domain that we talked about last chapter. We could say any pi over 2 plus some multiple of my period later, right? Notice my period here is 2 pi, and we talked last time about how this is multiple of, right? It's kind of looks like a mess. Or even for sine of x, it's going to be messier. Even in this case, I have two different answers. Sine is 1/2 at pi over 6 or at 5 pi over 6. But notice that would be pi over 6 plus any multiple of the period later. Or it would be 5 pi over 6 plus any multiple of the period later. Again, that's just like a mess to write. So instead, we restrict our domains, right? This is a nice, easy once around the circle. When does my x coordinate equal negative root 3 over 2. So on the left over here, we're using unit circle here. You're going to be responsible for knowing unit circle values again. X is root 3 over 2 is the bigger one, so bigger negative. It's going to be 5 pi over 6 or 7 pi over 6. And just once around the unit circle, that's all I need. But notice this, the only thing that changed is I'm going another half circle around. So I'm going to hit 1, 2, 3 answers there. I'm going to hit my 5 pi over 6, my 7 pi over 6, and then I'm going to hit this again. But notice it's going to be 2 pi away from the last one, because every 2 pi I find a coterminal angle. So these coterminal values, I can add 2 pi. Notice it's going to be 12 over 6 and get that 17 pi over 6. Right, so I can get 3 answers on those. Similar thing's going to happen here, and of course we're going to have to solve for sine of x. We treat it like 2u minus 1 equals 0, so I can get that 1/2. And notice that x is actually twice around the circle. So yes, we know that our sine is 1/2 at pi over 6 and 5 pi over 6. But I'm actually going to have to go twice around the circle, so I get those 2 answers. But I also have to say, put 2 pi away from this. Right? 2 pi away from that's going to be that 13 pi over 6. And I'm going to have to say 2 pi away from that. Right? Going twice around the circle, I go around and then there. So it's 2 pi plus this extra distance again. So 17 pi over 6. So notice I'm going to get 4 answers here. Notice I never get an answer bigger than this. 4 pi over 6 would be 24 pi over 6. So of course 17 pi is no way bigger than 24. If I tried to add again, if I would look, gotta keep going around. If I tried adding 2 pi to this, I would get 25 pi over 6, which won't work, right? So that's the other reason I know that I have to stop, because I have to stay in my restriction. Tangent we know can be a little bit trickier, right? Tangent is going to be 1 at my pi over 4, and then straight across the circle at 5 pi over 4. But notice it says I need to go not from 0 to 2 pi, but negative 2 pi to 2 pi. So I need to count this angle and that angle as well. So of course I get my pi over 4 and my 5 pi over 4. But to go backwards, sometimes I like to just put them in order. To go backwards, I can subtract 2 pi to get to my previous answer. So I'm going to subtract 8/4. Right, this is 3/4 pi, but backwards. And I can subtract 2 pi and get my negative 7 pi over 4. Again, this is 7 pi over 4, but in that negative direction. Notice never am I getting bigger than my 8 pi over 4, never am I getting smaller than my negative 8 pi over 4, right? Notice this is tangent, and you're like, Ms. Mickle, why are you adding 2 pi? Tangent's period is pi. You're exactly right. You can actually always, whenever you find one, just add pi or subtract pi or subtract pi. Since it's tangent, right? Tangent's period is pi. This only works for tangent. It doesn't work for sine or cosine.